Hi everyone. So as per the discuss in the last video, we have seen that the derivations or the expression for the discharge over the triangular notch and weir, as well as for the discharge over the rectangular notch and weir. Different formulas, and today we are going to discuss what are the different advantages of triangular notch or weir over the rectangular notch or weir. So before starting this discussion, we are going to revise the derivations which are already discussed in the last lecture or video, that is discharge over a rectangular notch or weir, in which we have considered the horizontal strip of water that with thickness dh, and then area of strip was taken as L into dh, then theoretical velocity that is taken as under root twice gh, then discharge q dq, that is cd into L into dh into under root twice gh. So for the total discharge q, we have integrated the discharge dq equation with the limit 0 to h to get the total discharge, or equation to calculate for the total discharge q as and finally we get the equation, that is q is equal to 2 by 3 cd into L into under root twice g multiplied by s to the power 3 by 2. This is the equation. By using we can calculate the discharge over the rectangular notch or weir. Then another derivations is for discharge over the triangular notch or weir, in which same we have considered the same parameters such as capital H, that is the head of water above V notch, and theta is the angle of V notch. Same parameters are considered here, that is theoretical velocity of water, that is under root twice gh, area of strip as 2 times of AC multiplied by dh, means 2 into capital H minus small h multiplied by tan theta by 2 into dh. dh is the thickness of water strip. So discharge dq through the strip is given as we have seen that is equal to 2 times of cd into capital H minus h tan theta by 2 dh into under root twice gh. So to obtain the equation for total discharge q, the above terms or equation, we integrate the above equations with the limit 0 to h, and finally we get the equation, that is q is equal to 8 by 15 cd into tan theta by 2 under root twice g into s to the power 5 by 2. By using this equation we can calculate the discharge over a rectangular notch or weir. If the value of cd is given as 0.6, then for right angle V notch the discharge q is calculated by using the formula Q is equal to 1.417 s to the power 5 by 2. Okay. So, we are going to our main topic, that is the advantages of triangular notch over the rectangular notch or weir. So, the advantage number 1 is that the expression for discharge for right angle V notch or weir is very simple. So, the derivations or expression we have seen about the triangular notch is very simple, or and which is explained or mentioned in the advantage number first, that is the expression for the discharge for a right angle V notch or weir is very simple. Number 2, that is the for measuring low discharge, a triangular notch gives more accurate result than the rectangular notch. Number 3, in case of triangular notch, only one reading only one reading, that is H, is required for the computation of discharge, and last one is the ventilation of triangular notch is not necessary. Here ventilation of triangular notch is not necessary. Number 4 advantages is ventilation of a triangular notch is not necessary, which is not showed in this slide. Okay, these are the advantages of triangular notch or weir over a rectangular notch or weir. So, next topic is the discharge over a trapezoidal notch or weir. So, trapezoidal notch or weir is the combination of rectangular and triangular notch or weir, means it is the additions of or summation of, in simply it is the summation of rectangular notch and triangular notch, means rectangular notch plus triangular notch is equal to trapezoidal notch or weir. Thus, the total discharge will be equal to the sum of discharge through a rectangular weir or notch and discharge through the triangular notch or weir. Let capital H and capital L are the height and length, height of the water over the notch, that is the H, and capital L is the length of crest of notch. CD1 and CD2 are the coefficient of discharge for rectangular portion, and CD2 is the coefficient of discharge for triangular portion. So, total discharge Q is equal to 2 by 3 into CD into L into under root twice G into S to the power 3 by 2. This equation, or this is the equation for discharge through the trapezoidal notch or weir. And another equation, that is in addition, plus 8 by 15 CD into tan theta by 2 under root twice G into S to the power 5 by 2. This equation is for it can be used for the discharge through the triangular notch. So, here you can see it is the discharge over the trapezoidal notch or weir is the combination of both the notch or weir, that is triangular and trapezoidal notch. So, next topic is the effect of discharge over a notch or weir due to error in the measurement of head. For an accurate value of the discharge over a weir or notch, an accurate measurement of head over a weir or notch is very essential, as the discharge over a triangular notch is proportional to s to the power 5 by 2. And in case of rectangular notch, it is proportional to s to the power 3 by 2. A small error in the measurement of head will affect the discharge considerably. The following cases of error in the measurement of head will be considered. That is, number 1 for rectangular weir or notch, and number 2 are for rectangular weir or notch. So, for rectangular weir or notch, the discharge for rectangular weir is given by the equation, that is Q is equal to 2 by 3 C D into L into under root twice G into s to the power 3 by 2 is equal to k to the k into s to the power 3 by 2, where k is what? K is the 2 by 3 into L into C D into under root twice G. This is the value of k. Okay, dividing dq by q is equal to 3 by 2 dh into dh by h. Equation shown that the error of 1% in measuring h will produce 1.5% error in discharge over a rectangular weir or notch. So, this is the one case for rectangular weir or notch. Second case is that error in the measurement of head for the triangular weir or notch. So, the discharge over the triangular weir or notch is given by the equation. You know that Q is equal to 8 by 15 CD into tan theta by 2 under root twice G into s to the power 5 by 2. Same parameters are mentioned here or used here, that is k is equal to 8 by 15 CD into tan theta by 2 into under root twice G. After putting this parameter in the main equation, we get the dq is equal to k into 5 by 2 s to the power of 3 by 2 into dh. So, dividing dq with dividing this term or simplified this term, dq is equal to q, dq by q is equal to 5 by 2 into dh by h. So, this equation show that an error of 1% in measuring h will produce 2.5% error in discharge over a triangular weir or notch. So, effect of discharge over a triangular over a notch or weir due to error in the measurement of head. We have discussed two cases of error in measurement of head, that is one for the rectangular weir or notch and another one is the cases of error for the triangular weir or notch. In next video, we will see the discharge or the derivations for discharge over a rectangular weir. So, be prepared of today's lecture for upcoming for the study of upcoming videos. So, thank you for watching and we'll meet in next video. Thank you.